So I woke up this morning and realized I'd run out of deodorant in my gym bag. So I went and grabbed some out of the cupboard, put it in the gym bag, and went to the gym. When I got done, I know you guys, I do go to the gym. Trust me, I do. I know you guys have done that. Everybody's done that. So when I got to the gym, I had done my business there, and it was taken after getting out of the shower. I got up and decided that I need to put on a little deodorant. So I pulled up all the stuff, started turning to get some deodorant out of it. Well, either I was going the wrong way or something was defective. This thing snapped right off. I'm like, well, I'll just be a little stinky today. That's okay. But the bigger deal is now I've got to go back to the store. I've got to then return the thing. I just don't want to deal with that. I have to drive a lot every day to get back and forth to work, and I'd just rather not deal with it. So I chunked it all back in the gym bag and decided I'd make a project out of it. Help me smell better using 3D printing. So here's the deal. I got an idea how big that is. I can measure those things. I also looked, if you'll look right here, there is a hex opening. That hex opening just happens to fit a 5/16" nut. Now, I didn't pull out my metric ones on this, so maybe there's a metric thing in there, but it fits it pretty good, so that's where I'm going to roll with. I got sizes of this, I got size of that, I know where it is, it's nice and circular. I've got Fusion 360, I can make a model, and we can make myself smell better using 3D printing. So, I'm going to model it up, and I'll show you guys doing that. I will show it printing, and I'll show you the results. So, hang on, here we go. Okay, so we know what the problem is. Now let's model up our solution. Pretty straightforward kind of guy. So I did practice a little bit, I'll be all honesty, but I'll show you my mistakes and where I made mistakes at. So the first thing we want to do is we need to make a sketch. And there's a couple of ways to do this, but effectively this is a hex column on top of a round cylinder. That's all it is. So let's go do that and let's make it really easy. So we make a circle on the x-axis. Get my calipers out. Seems I need to make this, let's call it 30. It says 33.5, and that's just on the outside of that. So let's call it 33 millimeters in diameter. So I'm going to say click. 33, tell it to go, and I need a height. It's a little difficult to get a hold of. Yeah, I'm going to call it, it says 12.8. I'm going to call it 12 in this case. Actually, I want just a little shy of that, so let's call it 11 this time. Alright, so then what we need to do is, that's 33, see we're all dimensioned up, which is great, and we can do this press pull business. Select this. I want to make a distance of 11 millimeters. And I'm making a new body, which is fine. And away we go. Dude, we're almost done. No. Let's do a couple things first before we go any craziness. So I'm going to zoom in here. And one of the first things I want to do, I want to grab that line right there, and I want to grab that line right there, and I want to make a chamfer, and I'm going to make the distance, what's 2 millimeters look like? I look good to you guys? So now what we have a chamfer and a nice little donut here. Back to my home, make sure I'm not looking at the right thing. Now the next thing I'm going to do is I need to make some indentation because that's smooth all the way around, and you know when you're getting out of the shower and your hands might be a little moist, you need something to grip on it. So let's make some indentations on that. Start a sketch, and we're going to want a circle, and I'm going to do a center point circle. Okay, move this around a bit. Now it says it's right here where I'm at, but I'm not going to want to put it on the sketch. I'm actually going to drag the circle out here and rotate it in here. Alright, then I'm going to do a press pull on this noise. Put this thing around so I can see what I'm doing. I'm going to select my surface and I'm going to pull. And because I'm going through the object, it knows I want to cut. Okay, cool. What do you think about that? Nice little indentation. Not that big a deal. However, those edges are a bit sharp and we can do it a little bit better. So I select that edge there, hold down the shift key, select this edge here, and right click and say, give me a fillet. 1mm fillet, what do we got? A nice little rounded edge of that. If I give it 2, actually, I think I want that hole a little bit deeper. So I'll say okay. I'm going to back up to that instruction and say edit sketch. And this one, you do that. I don't want this one. Wow. A little deeper than that. So let's do this. Give me a dimension on that. Let's go 7. About 8. Just double clicking on that dimension line. Oh, I think that's pretty good right there. Look, it looks way better. Cool. Now we stop all this sketchy. What do you guys think about that? Pretty cool. I thought it was pretty cool. We're back to where we are. Now what we want to do is we want to create a pattern. So we'll go into the create pattern and we're going to do a circular pattern. And we're going to select features, and the features we're going to select are that extrude and this fillet. So you see what we've got selected there. Now we need to select an axis, and everything needs an axis. In this case, since I put this at the very middle of all this, I can select the Z-axis. Now what you'll see is already is it's giving me 3 places it's going to be. So I can sit and rotate up to 4, 5, 6, 7, 8, 9. When I was testing this, I went up to 12. That seems a bit much to me. Seems a bit much. What do you guys think? No, you can't answer me right now. This is recording. But I think 8's pretty good. I mean, as far as knobs go, that's a good looking knob. Alrighty, now. Next thing we need to do is we need to put a bit of hex nut on the top. Select the plane. We're going to sketch up a polygon. We want to get a circumscribed polygon right in the center because that's how we roll. Now, because I've done this before, we want 6-sided, so it gives us our hex. Also, when I initially played with this, I felt the 5/16 inch hex key actually fit better. It went further into the hole because there's a slight taper to the hex hole. I'm sure that has to do with centering up and that sort of thing, make things easier to go, easier to do. I backed off of that just a little bit. That it actually absolutely fits the hole. I felt I could get further in and give a little more control to make the thing just a little bit taller on the axis there, with the 5/16, and that 5/16 measurement is across the flat, just under 8 millimeters anyway. So 8 millimeter there, 5/16. Oh no, that's 8 millimeters. Sorry, just shy. 8 millimeters versus 7.94. So we're going to go right at 8 millimeters across there. So as we come up here, I am going to tap in. This is a radius, not a diameter. 4 millimeters. In fact, I'm going just a little shy here. 3.94. And that'll get us right at So what is 3.94 times 2? That's 6 plus another 180 plus another 6. It's 188. So right at 7.9 is what we got going on there. So that is our hex nut. I'm going to stop the sketch. And now we're going to do one of their press pull things. And because I've done a little measuring, that measure needs to be about 8 millimeters tall. And I'm going to go just a little, 8 millimeters, good. 8 millimeters tall. And because I know there's not going to be a lot of strength on this, there's not going to be a lot of twisty whatever, but just in general practice, anytime you have a hard edge, a hard right angle like that, and you're going to be twisting and things, that's where all your force is going to be. So I want to go in here and more for aesthetics than anything else, and just general best practices. I believe it's a general best practice. Right click, put a fillet in there, and we're going to do a radius on that fillet, 0.5 millimeter. 0.5 millimeter. Yeah, that'll get us a couple of layers of a slope up into the flat. Actually, if I did 0.6, that'd give us 3 layers. We're printing this at 0.2 layer heights. So that's good. And then of course on the top, I can't leave that go untouched. We're going to camfer that a bit. We're going to give it, let's see what's 1 millimeter look like. Oh, it looks too much. Let's give it 0.6 here. So we get 2 or 3 layers of that. So there you go. So you guys, that's our nut. All lined up. And then we need to make it. So I've got Cura already fired up here. So I'm going to say 3D print. I have Fusion Suite 360 already set up to go to Ultimate Cura, which is what they're calling the Cura 3.1 and above stuff. It used to just be Cura. I'm going to select the object. It'll give me a rendering of all the things it's about to do as far as mesh points and things it's going to fire up and show and do, and you know, all these are like just everything's a triangle. People think things are flat. No, they're just big triangles. So I say okay. So now I go over to Cura. And we have the model. I've already set a bunch of things over here in Cura. And if I take the standard solid view, you'll see what we're looking at there. Decent thing. Go into one of the things you need to check. Every print you do, you need to check this. Is how your infill gets laid out. Do a little bit of trial and error. I've decided about 15% infill is all it needed, and I decided line was the infill type just because I've got these big large flat surfaces as they go up. I'm doing this brim here because I will be printing this initially in PETG, and I want to make sure I get a nice even flow of material out before I start printing the real deal. And and every single one of these prints you need to check the run through the layers. So you can do this a couple times. You got tons of layers and everything, but I just clicked on the one there so I can use the up arrow keys. So I can go up and down by one layer at a time. So I can see how my infill is getting laid in. I can see that I've got 3 wraps. It's giving me about 1.5 millimeters. You can probably do this with 2, but I'm just, I don't know, the extra layer makes me feel good, so I do it. The bottom layer I've got set. I make it so that both my bottom and top are the same as my outside walls. It's personal preference. I think outsides need to be equal all the way around, as much as they can be. And so, yeah, much as they can be. So as we're going up, watching the infill as we go, this is extremely uneventful. Here in just a little bit, though, we will get some more fun stuff going on. So now, this is one of the reasons I chose the lines, by the way. You see, there's the first of the top shell of the nut going in, of the knob. And now you can see how it's kind of been closing in just a little bit to get to the final top shell of the knob. And then we, on top of that, because it sucked it in a bit, we've got a whole bunch of shells that's going to make that adhesion between those two layers great. And as you'll see, it sucks in 3 times, and then we start going up. And then you notice I've got this infill right here that just goes right through the middle of it, connecting a bunch of these walls, 4 of the 6 walls together. So that should be okay strong for what we're doing. As we go up, you'll see it just continue to go up, and then we'll start putting an infill. The very first infill goes across. That's probably going to be really sloppy and ugly, but the second one, that one right there, is probably pretty good. And by the time we get to the camphor at the very top, it should be a pretty nice thing. So that is how we're going to print this thing. And then, so I guess it's time to do a little print action. Yeah, it should be time for a time lapse. Couple of prints of this. I had dealt with the printer a little bit, and I did a test fitting of our model. Turns out I was a little bit simplistic on how things needed to work and do, and there were some things that were going a bit crazy. So what we're going to do is we're going to change it up a little bit. All you guys that are fusion experts, prepare to laugh at me because I'm going to show you me just trying to do this. First time we need to rewind. In fact, all the way back to the extrude. I'm going to edit the feature because we extruded 11 millimeters. We only really want to extend that. I'm going to make that 10 millimeters. Okay. Then we're going to add a feature. A sketch. Create a sketch. And then we're going to want a circle. C key. And we need to plate that circle with a diameter of 26 millimeters. 26 millimeters. Yep. And then we're going to do a press pull on that. And we're going to make that go up 1 millimeter. In fact, no, 1.5. All right. Because that right there is an inside lip that's going to 1 millimeter seems about right, and it was making it hard to turn. That's the first of our changes. Let's see if it goes forward and does what I think it should do. Whoa, look at that bit of goodness right there. Now we're going to change that a little bit. So we got that lip going on there. We got that. All right, I think I'm good with that 26 being there. 0.2 of a millimeter on either side. We're probably good with that. Next thing we need to do, oh, that chamfer's got a problem on it. Yeah, it does. I'm going to delete that. Review warning. 6 reference edges are lost. Try editing this feature again. Reselect the lost edges. Okay, we can do that, and we will do that. So what I need to do here is I'm going to edit that feature. No. Not that feature. This feature. Going to edit that feature. We got it going up 8. We actually need to make it go up that's off this bottom here, and we just took off one of them. So we need to make it go up 1 millimeter more. All right, 1 millimeter more. And we need to make, I wonder, how do you do this? In fact, I know what I'm going to do on this. Because it's such a simple thing, I'm just going to delete click, delete, click, click. I want to even edit that sketch. I'm just going to delete that. That's the pattern. I'm going to delete all of that because really I want to edit this screen. And I'm going to sketch, create a sketch. We're going to do a polygon. It's going to be a circumscribed. Click here, 4.2 millimeters. Because it will shrink slightly. Because I measured across the flats in the internal the very opening of the hex entry in the bottom of the deodorant, and that read 8.44 millimeters. So that extra tenth of a millimeter, I'm going to give into slack. I'm going to call that done. I'm going to press pull this. We're going to go up 8 millimeters. Okay, we have a taper angle, and yes, we need to do that. How many of you guys got your geometry close at hand? And I'm sure that Fusion could do this. In fact, I know it's my inadequacy. So let's see if we can do a little Bing search. Said I show you the good and the bad. So right angle, triangle, calculator. Well, cool. I wonder if this thing's any good. No idea. Don't even know who they are. Okay. So look at this. Angle 60 degrees. And it gives me the A and the B. So we'll use C as our right triangle here. So that'll be 90. One side is going to be 0.44. The other side is going to be 8. Right? And I say calculate it. Look at that. It looks as though the taper angle on this is because we got to taper it in. It's 3.148 degrees. Wow. Let's see what happens. It's either 3.148 or 86.4, depending on how Fusion's done this. This is the first time I'm ever doing this. So 3.148 degrees. What happens? Well, almost what I wanted. It got bigger. So let's edit this feature. Minus. I think that's more what we want. What do you think, fellas? I say fellas. Guys, folks, peoples, human beings. I think most everybody's included in one of those groups. Okay, I'm going to do a couple of things now. Just some little smoothing things. That's no big deal. I think that looks actually really good. And so let's do some things like we were doing before, a little smoothing. I'm going to put a little fillet on here. Just so it rounds over. Me and sharp edges don't get along too well. I'm not going to do much there. 5 millimeters. 0.5. That looks pretty good. Round it slightly. And then we're going to select every one of these. Oh, that didn't do what I wanted to do. No. We're going to fillet those. Why did we do that? Didn't we do 0.6 on that so we get several layers before? And then we're going to do the same thing we did up here. Just clicking the edge and holding the shift key. And we're going to chamfer those. And I think we got another, what, ½ millimeter or so? It's 0.6 again. See what we got. That looks pretty good. I think it looks really good, in fact. So what we're going to do now is go print this out. Go over to Cura. Open it up. Let it slice. It's a little different than before, not much. You can see that we're still getting our nice X hash in the middle there. Take about the same printing time. You get that nice ring that goes around. Oh yeah, I bet that's going to be awesome. Okay, here goes another print. The results of all the stuff I've been playing. It's been a little while. You see I've changed shirts, and I've got my other printer going in the background doing another project. So, let me show you the good and the bad, as I always promise. I'll show you the good and the bad. So, this yellow stuff is ABS, which is my TiVo Trench, and my current favorite, but I rebuilt it and I haven't really tuned it in very well. I just wanted to print that on there just to see, but as you can see, kind of hard to see. Maybe I can get it focused in there. It's got some, I've got some heat issues going on there, and see if I can do something about the light right fast. Da-da-da-da. That's maybe a little better. Okay. So, get it focusing in. You see, I've got some heat issues on the thing. I need to set up my other camera so I can get a better close-up. But actually, it came out pretty decent. But it's not. It's actually kind of a busted print because it's still not going together. I had a weird thing where Cura was stopping. Well, I said Cura. Both printers would stop for some reason, and I think it's because we got bad G-code. And so I just restarted Cura, wiped out my file, sliced it again, and then I started getting these prints out. So this was the first print, and where I mismeasured, and I got a really sloppy, really sloppy hex thing there. I don't think I was blowing enough fan. I wasn't blowing any fan at all, actually. Pet G. On this small stuff like this, I think because the layer time is so small, I think you really probably need a fan on that. That's okay though, because that's too small anyway. My next attempt was this one. Lots better. Lots better. Of course, all this has been really good and a nice sheen to it. But it was too tall and didn't fit in very well. And so we chunked that away too. Okay. This was the next attempt. And it actually worked. So you see the hole there, this thing goes in. The problem is it butts right up against that thing and didn't really want to turn very well. And I couldn't tell what was going on, whether I was actually turning or not, and I couldn't really see some things are going on. And it was this thing is really just riding on this up here, and so it was really hard to tell what was going on. And I learned from that these sides here, I did the sides straight up and down, and you'll see that you saw that in the video in the working in Fusion. And I thought maybe that would be good enough. In fact, it probably worked just fine. I put a little glue on this stuff, enough glue to sock up the way. Suck it in there, it would work just fine. However, I didn't want to stop there, so that goes away. All right. So this is the final one that I have. It's still just a little bit loose on it, but it does a really good job. And I need to do some more heat abatement at the very top, because it does get a little soft and mushy. But the sides came out really nice. Glassy bottom, just like you would expect, and this little lip here actually helps. So the lip fits right inside this lip here. The bottom base here is 8.4 millimeters. It shrinks up to 8 millimeters at the top, which matches that pretty closely. Not exactly, because I couldn't get a pair of calipers down there to actually measure that bottom side. And you put it in there, and it fits. It's a little bit of slot there, but in the whole world of things, I glue it in there a bit, and a few more turns. Oh, I was going the wrong way. It's probably why I broke in the first place. You think I'd have done all this deodorant, I'd have figured it out. Oops. Wrong way again. It can only go one of two ways, right? And when I get done with this, I'm going to glue this together, and I will have me the most expensive. There it goes. See it squirting out finally at the top. I'll probably have me the most expensive $3.50 worth of deodorant ever made. But I'll smell better, and I use 3D printing to do it. So, leave me some comments at the bottom. I'll have links to this thing in Thingiverse, and all those sorts of things. So again, leave me some comments, ring the bell, subscribe up, and I'll see you guys later. And like I said, whether it's from my failures or your successes, hope you learned something today.